Hi, this is Wendy Lightheart, and today we're going to be looking at adding and subtracting rational expressions that have the same denominator. So if we want to add rational expressions with the same denominator, then we simply add the numerators, and then the same denominator will get copied over. So only the numerators will be added, and then we'll put that over the common denominator. And then lastly, if possible, factor everything to see if there are common factors you can cancel in order to simplify that result. So let's look at an example. Here we want to add the rational expressions that each have a common denominator of 7. So we add the numerators and place that sum over the common denominator. So notice that the only thing being added together here are the numerators. The denominator simply gets copied over. So now we can combine like terms in the numerator, which will give us 8x minus 5 over 7. And then next we would factor and simplify if possible. But as you probably guessed, this does not simplify. Let's look at another example. Here we want to add these two rational expressions that have a common denominator of x minus 1. So we add the numerators together and we'll place that sum over the common denominator. Next we would simplify the numerator by combining like terms. And then we'll also make sure and put those terms in order of descending powers of x so that we can possibly factor that. Now we would want to try to factor so that we could possibly simplify, and this numerator does factor into x minus 1 times x plus 6, which means the x minus 1's can cancel, which leaves us with just x plus 6. Let's look at another example. Here the common denominators are x squared plus 3x. So we start by adding the numerators and placing that sum over the common denominator. When we combine like terms in the numerator, we get 2x squared minus x. And now we want to see if we can simplify. So we factor the numerator and the denominator completely. And notice we do have a common factor of x in the top and the bottom that we can cancel, which leaves us with 2x minus 1 over x plus 3. Now let's look at how to subtract rational expressions. It's very similar to adding rational expressions with the same denominator. We simply subtract the numerators and put that difference over the common denominator, and then, if possible, simplify the result. Now this will be a little bit more difficult than adding rational expressions, because if q is a polynomial, we will have to distribute that minus sign through the polynomial before we can combine like terms. So here's an example. The common denominators here are x plus 2, so that's going to be the denominator of our answer. And we will place the difference between the numerators above the common denominator. Now notice I put parentheses around the numerator of the second fraction because we need to subtract the entire numerator, not simply the first term of that numerator. So we would distribute that negative sign through so we can get rid of the parentheses, so that we can combine like terms. So that will give us a negative 5x and a negative 13. And when we combine like terms, we have x squared minus 5x minus 14 in the numerator. And now we factor and simplify, and the numerator does factor into x minus 7 times x plus 2. And notice that we have common factors of x plus 2 that can cancel, which leaves us with x minus 7. Let's look at another example. Here our common denominators are x squared plus x minus 6. So that's going to be the denominator of our answer, and the subtraction will occur between the numerators. And again, we're subtracting the second numerator, so we put that in parentheses to make sure that we subtract the whole thing, and then we have to distribute that negative in order to get rid of the parentheses, so that will make the 2x negative and the negative 1 positive. And now we need to combine like terms. So when we do that, we get x squared plus 4x plus 3 in the numerator. Now that the top and bottom are simplified as much as possible, now we need to see if we can simplify the rational expression by factoring the top and bottom completely. So if we factor those, the top will factor into x plus 1 times x plus 3, and the denominator will factor into x plus 3 times x minus 2. Notice that we do have common factors of x plus 3 that can cross-cancel, which leaves us with x plus 1 over x minus 2. Now we're going to look at a few examples where the denominators are not exactly the same, but they are opposites of each other. So binomials of the form a minus b and b minus a are opposites or additive inverses of each other. So whenever you see the same binomial and it's subtraction between the terms, but the terms are in the opposite order, we call those opposites. And if you were to add those two expressions together, they would add up to 0. That's why we call them additive inverses of each other. So when one denominator is opposite or additive inverse of the other, then what we want to do is we want to make them common denominators. So we want to make them equal to each other. And the way we do that is to first multiply either one of those rational expressions by -1 over -1. Remember, we can always multiply top and bottom of a fraction by the same number, and it doesn't change the value of that fraction. And when we do that, it will make the denominators equal to each other. Then we proceed to add or subtract the rational expressions depending on the operation between them. And as always, if possible, factor and simplify your result. So let's look at an example. Notice that these denominators are opposites of each other because we have x minus 3, and then the other denominator is also subtraction, but the 3 is listed first and the x is listed second. That's how you can identify opposite expressions or denominators. So what we want to do is multiply one of these expressions by -1 divided by -1. Now it doesn't really matter which one you multiply by -1 over -1, but usually we multiply the one that has the constant listed first because it looks kind of different than the others. It's not usually how we write our binomials. Usually we put the variable first. So we're going to multiply the 15 over 3 minus x by -1 over -1. Now if you distribute that -1 through the denominator, you'll have a -3 and a positive x, which is the same as the denominator in the other fraction, a -3 and a positive x. And then we'll just reverse the terms, putting the positive x first and the -3 second, so that they look the same. And then the -1 we multiplied times the 15 on the top makes that 15 a -15. Now if that was a polynomial on the top, you would have to be sure to distribute that -1 through the parentheses. Now we subtract the numerators, and when we subtract a -15, that becomes plus 15. And then we factor and simplify. So the numerator factors into x minus 5 times x minus 3. So we can cancel the x minus 3's and we're left with x minus 5. So that's it for today. So remember, when you're adding and subtracting rational expressions, it's only the numerator that's going to get added or subtracted. The denominator that you have in common simply will be the denominator of your answer. Have fun with those rational expressions. Bye-bye.